In this video, I will show you how to use the fracturing tools in the ANIMAX add-on. Let's get started. To follow along with this tutorial, you will need at least version 2.3 of the add-on and Blender 4.1 or higher. The fracturing tools are located in the Fracture tab, but before fracturing you can select an object, then press the Check Object button to check if the object could be fractured without issues. If I delete some vertices and then check again, I will get an issue because the mesh now contains a gap. So make sure to check your object before fracturing it. The add-on provides 3 different fracturing tools. The first one is Split, which contains a set of operators to split the outer shell of the object. Let's select the sphere and then run the operator Split the object. Give the new collection a name, and you have the options to fracture the object or keep it and fracture a copy. Then press OK. You can play with the random seed to change the randomization pattern, and you can also specify the number of points to generate the shards. Here you can subdivide the mesh. You can also triangulate it, and with the solidify option you can add thickness to the shards. To assign a different material to the interior faces, use the material offset parameter. The index of the first material is 0, the second is 1, and so on. I will set it to 1 to use the second material. You can also use a different material for the rim faces using the same principle. The cut edges parameter makes the shapes of the shards irregular and more interesting. This last parameter is for previewing the shards. When you are happy with the result, you can press the apply button, and the add-on will convert the shards to individual objects and put them inside a new collection. Then you can exclude that collection and animate its objects. The second operator will allow you to convert the faces of an object into individual objects. Like the previous operator, just give the new collection a name and then press OK. The last operator will convert the mesh islands into individual objects. And for text objects, you have an operator to separate the letters. Moving on to the next tool, its name is Slice. It will allow you to slice an object using a group of planes. To use it, in the Mesh Input panel, you will need to select a mesh object. Then, in the Mesh Cutting section, you can add a slicer. When you press the Execute button, the object will be sliced. Now it's possible to preview the slicing planes. Just enable the option Preview the Cutters. It's possible to change the color of the preview planes. From here, you can enable or disable the slicer, and you can double-click on the name if you want to change it. It's possible to change the scale of the preview planes. The slicer parameters are located in the Slicer Properties panel. The Count parameter changes the number of planes. The planes are distributed by default along the x-axis, but you can distribute them along any axis. If you distribute along the y-axis, you will need to set the Z rotation to 90 degrees to get the proper alignment. And if you use Z, you will need to set the Y rotation to 90 degrees. It's possible to randomize the rotation of the planes. The offset parameter controls the distance between the planes, and it's possible to randomize the offset. Then you can play with the random seed to change the randomization pattern. When the parameter randomize is enabled, every time you press execute, the add-on will change the random seed. It's a good way for quick experimentation. Using the parameter position, you can move the planes along the selected axis. I will change the Z scale of the source object and then execute the cutting. As you can see, the planes are not respecting the dimensions of the object. To distribute the planes inside the bounding box of the object, you can enable the parameter relative distribution. Next, I will add a new slicer along the y-axis. The global offset parameter controls the offset of all the slicers. You can use it to reduce the number of shards by making them bigger. To assign a different material to the interior faces, just change the material parameter to the index of the desired material and then execute the cutting. The remove doubles parameter, if enabled, will remove overlapping vertices before fracturing. The last panel is Output Mesh. Here, you can select the mesh to output the fracturing data too. If left blank, the add-on will generate a new object. You can enable the option Preview Shards to scale down the shards. And this is a handy operator for displaying the number of shards. When you are happy with the result, you can press the Apply button to convert the shards into individual objects. Just give the collection a name and then press OK. It's possible to save your cutting setup as a preset. To do so, use the plus button. If you haven't set up a presets folder, you can do it from here or from the preferences, just like the animation presets. And don't forget to save your preferences. This is the list of built-in presets. To load a preset, use this button. This is the Cubes preset. Pyramids preset is nice, but it produces a big number of shards. You can reduce it by increasing the global offset and then fracture again. Just like the animation presets, it's possible to filter them. The ones with the A icon are the built-in presets and the C icon is for your custom presets. You can also filter them by their names. Here we have some options. You can duplicate the selected slicer, delete all the slicers, and enable or disable all of them. The next tool is Voronoi, which fractures the objects into a Voronoi pattern, just like the Cell Fracture add-on. Its functionality is divided into two panels, points and shards. You can use the Fracture button to execute the fracturing. From here, you can control the number of points that are used to generate the Voronoi cells. We have two methods to distribute the points: random and grid. The grid method produces shards that are close in size. You can use the slider random to control the randomness of the points. For example, if you set it to 0, the shards will be cubic in shape. It's possible to get the points from the annotation tool. Just enable the option and then draw on the object that you want to fracture. And you can control how many points to use using the percentage slider. In this example, half of the points are coming from the annotation tool and the other half are the generated points. If you set the percentage to 100, the add-on will use only the annotation points. We have another method for getting the points named Advanced. Here you can use the points from a particle system or any object vertices. Let's add a particle system to the sphere, setting the end frame to 1, the source to volume, no physics, and the points to 250. With the particle option checked, I will execute the fracturing, and this is the result. You can also change the source to vertices. I will use an icosphere, then I will scale it down, and then I will put it in a new collection. You can put as many objects as you want inside that collection, then select that collection here. Now all the points of all the objects inside that collection will be used to generate the shards. The result of the icosphere is quite interesting. It's also possible to use the points of a curve object. You need just to put it inside the collection. Here, I duplicated the curve to get that result. You can also use both the particles and the vertices. Just hold Shift and left-click on the other option. In the shards panel, you have more control over the shape and look of the shards. For example, you can add a gap between the shards using the margin parameter. And like the other tools, you can assign a different material to the interior faces. You can scale the shards. If you set the Z scale to a very low value, you will get these vertically long shards, which are useful for creating wood shards, for example. And if you also set the Y scale to a low value, you will get this kind of result. Just keep in mind that setting the scale to 0 could lead to some bad results. The add-on uses the Boolean modifier to extract the shards, so the options are available here. The fast solver is obviously faster, but it's less accurate, like in this example, but it works fine using the exact solver. When using the add-on, we recommend that you check and fix the object before fracturing. But sometimes you could deal with a photo-scanned object like this one, where fixing it is a nightmare. If we fracture it using the default settings, we will get some errors. In that case, you can enable the hole tolerant option, and it produces a much better result. Both of these options, hole tolerant and self-intersection, could improve the result with the cost of increasing the fracturing time considerably because they are computationally expensive. This tool also provides some extra options. The first one is Interior Vertex Group. When enabled, the add-on will create a vertex group for the interior vertices, named Interior Verts. One use case of this feature is that you can select all the shards and make sure one of them is the active object, go to Edit mode, deselect all the vertices, then select one of the interior vertices, or you can simply use the button Select of the vertex group. Then go to Select Similar Vertex Groups, and then delete the selected vertices. And you will end up only with the exterior faces, and you will need to set the origin to geometry for the objects to be animated properly. The second option is for setting the shading of the interior faces to smooth. The next option will transfer the normals from the source object to the shards. When fracturing using the default settings, you may get some minor shading artifacts. They are not a problem when using a textured object, but with a smooth object like this sphere, this option is very useful for fixing the shading. The next option will allow you to make the edges between the interior and exterior faces sharp. It's used primarily for shading, but it could also be used to create some interesting shapes. First, select all the objects inside the collection and make sure one of them is the active object. Deselect everything, set the selection mode to Edge, select one of the sharp edges, then go to Select. Select Similar, Sharpness. After selecting all the sharp edges, press Ctrl-I to invert the selection, then delete the edges. From here, you can press Ctrl-J to join the objects. Then convert the object to a curve. In the curve properties under geometry, increase the bevel depth and you will get these kinds of shapes. The last option is to split the sharp edges and to separate the exterior and interior faces. When you have multiple objects selected, the add-on will warn you because fracturing a large number of objects accidentally could freeze Blender or could lead to a crash. When you fracture identical objects, you will get a different result for each one of them because each object will have a different random seed. But if you want them to have the same random seed, just disable the parameter randomize seed. That's it for this video. If you need any help, feel free to reach out through the support channels. Thanks for watching and see you in the next video.